If you have ever felt like your ORM is fighting you, or that mapping your application objects into relational database feels like fitting incompatible puzzle pieces, you have experienced the impedance mismatch. It's a disconnect that has plagued the software engineering for decades. But is schemaless really the answer, or are you just trading one nightmare for another? Data models are arguably the most important part of software development. They don't just dictate how we write codes, but how we actually think about the problem we are solving. Most applications are built by layering data models on top of one another. Today we are looking at the big three of the data models: relational, document, and graph models. As a developer, you model the real world into objects or data structure by using these data models. So let's go over some of the key factors which help us determine which model to use. The relational model organizes the data into relations, which we call tables, where each relation is an unordered collection of tuples or rows. In this model, the schema is predefined. For decades, engineers have used this model where it was indeed the king and do it all for almost everything. But then came NoSQL. The term originally meant not only SQL, and it was born from the need for more scalability and desire for more dynamic schemas. Today, NoSQL is primarily represented by a document model, and the biggest driver towards this is something called the impedance mismatch. Translating the objects created by object-oriented paradigm into database table is most of the time painful, and it becomes like trying to fit a square peg in a round hole. For example, take a LinkedIn profile. It's a self-contained document. In a relational DB, you would have to shred it into multiple tables like basic info, education, and more. But in a document model like MongoDB, you store it as one big JSON document. This gives you benefits such as data locality. When you want to show a user's profile, you perform one query and get everything at once, rather than performing multiple joins across different tables. So if document models are so simple, why do we still use the relational models? This is because of the relationships. If your data has one-to-many relation, document is great. But as soon as you need many-to-one or many-to-many relationships, the document model starts to struggle. For example, imagine you need to store region of a user as string in every document. If that region name changes, you have to update every single document. To avoid such overhead, we normalize the data by creating central regions table and use the region ID. Such joins are handled brilliantly in relational model. In most document databases, you either have to emulate the join in your application code, which is slow, or duplicate the data and hope it stays in sync. You will often hear NoSQL databases are called schemaless. A more accurate term is Schema-on-Read because the database doesn't care what you write. It's the application's job to interpret the data when it is read. While a relational DB is Schema-on-Write, it ensures data conforms to a specific structure before it is even stored. Think of it like type checking in programming. Due to this nature, the document model is amazing for heterogeneous data, where different objects have different structure, but it can make migrations tricky because you might have old and new data formats coexisting in the same database, which complicates application code for handling these different formats. Additionally, we also have graph-like models. If your data is so interconnected that many-to-many relationships are a norm, not the exception, use a graph model. A graph model consists of vertices and edges. Vertices are the nodes or objects, and the edges are relationship between them. In a graph, anything can be connected to anything. This makes them incredibly powerful for social network, fraud detection, or tracking the food chain. Instead of messy SQL joins with a fixed number of steps, you can use declarative languages like Cypher or Sparkle to traverse the graph to an arbitrary depth. So what's the takeaway then? Document models should be used if the data is mostly self-contained and schema flexibility is required. Relational models should be used if there are many-to-many relationships and data integrity needs to be ensured through normalization. And graph models should be used if the data is highly interconnected and there is a need to traverse complex relationships efficiently. In a real-world scenario, most of the applications use a mix of these models alongside additional models such as key value and columnar. The data model you choose becomes the limit for your system's evaluation, so choose wisely.